Hello, High Point Chemistry class. I made this video to help you decide whether or not you would want to take physics next year. So, first of all, if you think of physics, you usually think of engineering. So, yes, if you're going into engineering, definitely you want to take physics. If you're going into something mechanical, suppose you want to be an electrician or a plumber, physics will definitely come in handy. Some other not so obvious career choices would be if you're going into medicine and you want to be a doctor, a veterinarian, you will need to take physics at some point. If you're going into scientific research, knowing how to do the math, that's where the physics comes in, applying the math is very important, and seeing how things work together, whether they're in the body or whether they're something physical outside the body, it's still physics. If you're going to be a math major, you definitely want to focus on developing your skills on applying math. If you're going into some sort of business where you need a strong math background, definitely physics will be helpful to you. Computer engineering, computer programming, physics will be helpful to you. Another option, another way to decide would be, what do you want to get better at your senior year? What skills do you want to get better at? So if you want to get better at math, I should say applying math, it's a little bit different than cold raw math. Personally, I think applied math is much easier, and I'll show you that in a minute. Reasons you would not take physics. For instance, if you want to go into a pure health-related field, such as nursing, speech therapy, counseling, something where you're going to focus on working with people, something like psychology, you would want to focus more on learning anatomy. If you want to go into administration, figuring out budgets, you might need physics. Working with people, maybe not so much. You might want to make your decision based on the format of this course. What type of a course would you like to take next year? There's a lot less lecture in physics. It's usually a smaller group, of course, because you're split in half. Half of the class is learning concepts, and at least half, if not more, is actually applying the concepts. So when we talk about applying the concepts, what we do is we work on some sample problems. We work as a team, usually teams of 4 or 5, and the tests are run like this. In class, you'll take the concepts. What does it mean for if you increase the force, what happens to the acceleration? Well, the acceleration will increase, something like that. At home, okay, you're going to have take-home tests, which are applied math, applying the physics, and you'll have a class to finish those, and there will also be a number of labs, at least one every other chapter, probably a little bit more than that. And if you're still not sure, just think again, what kind of gifts would you want to develop? And then the last question I want to answer for you is, how hard is the math? So what kind of videos do you want to watch? How far do you think you need to be? So in physics at High Point, and in a lot of general physics classes, including some for some pre-med, you can opt out of taking physics with calculus, or you can take it with calculus. This class is taught without calculus. We talk about some of what calculus means, some about how the equations may be derived, but we don't focus on how we derive the equations. I'll show it to you. We focus on using the equations. So here's a couple of examples. Again, this is not from the day 1. This is not until chapter 4. All right. So chapter 4, it says a change in velocity is equal to the velocity in the x direction squared plus the velocity in the y direction squared. So you're probably thinking that looks like Pythagorean's theorem, and you're right. We will use Pythagorean's theorem a lot in the first 5 chapters. So basically, yes, you're finding this side. You're also going to look for alpha or theta, the angle. The angle alpha is equal to the inverse tangent of the opposite, y, over the adjacent, v, velocity y over v sub x. So when you get to chapter 4, hopefully you've gotten that far. Excuse me, I'm knocking stuff over. Chapter 8, we talk about objects and we draw a lot of diagrams in physics. So I have a little diagram for you. We have acceleration of different objects, so it's a little bit trickier, I guess. The mass of the hanging object over the mass of the hanging object plus the mass of an object that might be resting on a table. And draw a table here. All right, and that's just the pulley connected to it. So the mass of that plus that times gravity, and I think you already know that gravity is 9.8. Or you could have two different hanging objects pulling each other down. They're both affected by gravity. So then the new formula is mass 1 minus mass 2 over mass 1 plus that mass 2 times gravity. So we'll show how to derive these, but then we will mostly focus on using them. All right, so the formula say the mass of the hanging object was 3 grams, the mass of the table object was 2 grams, what's the acceleration? And that would be it. And then it could, of course, ask for force because F equals ma. You could ask for that as well. Chapter 9, here it's talking about power equals force times distance times the cosine of an angle, right? So what is the power required to maybe push an object at an angle, all right, a certain distance, all right, and the angle is, I don't know, 60 degrees or something, all right, over a period of time, maybe 3 seconds or something like that. So you'll take all those numbers and plug them in and solve for power. And so that's the type of math that you will be applying. So if you're very comfortable with that, then you should have no problem doing the math in physics. And I will definitely help you if you're ever stuck on a take-home test. I will definitely help you with that. There's something else I wanted to cover, but I don't remember what it is. So if you have any questions, feel free to ask me.